You know that feeling, right? You're writing some Python code, you change a variable inside a function, and you're sure it worked, but then outside, it's like nothing ever happened. It's one of the most common headaches for coders, and today we are going to crack that puzzle wide open by mastering a core concept: variable scope.
Okay, so to really get this, let's use a little metaphor. I want you to picture your code as a big office building. In this building, scope is basically the security clearance level for your variables. Some variables have an all-access pass. They can go anywhere. Others, they're stuck inside one single room. And getting a handle on these clearance levels, that's the secret to writing code that actually does what you think it's going to do.
So let's start in the most public area of our building, the main lobby. In the world of Python, we call this the global scope. It's the first place you walk into, and pretty much everyone can see what's going on here.
So what makes something part of this lobby? Well, a global variable is any variable you create in the main body of your script. Not tucked away inside any function. This means it's public. Any part of your code can look at it, and just like that big clock on the lobby wall, it's there for as long as the building is open, or in our case, for as long as your program is running.
And here's a perfect example of how that works. Imagine you're in a private office upstairs. You can always glance out the window and see the time on that lobby clock, right? It's the same for functions. A function can always read a global variable. It can check its value, no problem at all. But notice I said read. Trying to change it from a distance? Well, that's a whole different story.
Okay, so let's leave that public lobby behind and step into one of those private offices. These are our functions, and each one has its own super restricted area, the local scope.
Now, inside these private rooms, the rules are totally different. Local variables are born inside a function. They're completely private. Nobody outside that office can see what you're scribbling on the whiteboard. And here's the crucial part. When the meeting is over, when that function finishes its job, poof, the whiteboard is wiped clean. The variable is created when you call the function, and it's completely destroyed the moment it ends.
So let's put it side by side. Global scope is all about wide open access and a long lifespan. It's a permanent fixture in the lobby. Local scope, on the other hand, is all about restricted access and a very short life. It's just temporary notes for one specific job. And honestly, getting this one difference is what saves you from pulling your hair out over most scope-related bugs.
All right, but this is where things can get a little weird. What happens when the name you scribble on your private whiteboard is the exact same name as something out in the public lobby? This is where we run into something called the shadowing effect.
So yeah, the big question is, if you have a variable named people out in the lobby, and then you go inside a function and create a new variable, also called people, which one does Python pay attention to when you're inside that function?
And the answer is, the local one wins. It completely shadows or hides the global one from view. Python always prioritizes what's closest to it. So inside that office, it only sees the local whiteboard. You've basically created a brand new, temporary, local variable that has absolutely no connection to the one in the lobby.
And this right here shows you the result perfectly. While you're inside the function, inside that private office, you see the local value. But the second you step back out into the lobby, you see the original, untouched, global value. The global variable was completely protected, totally unchanged.
Now, most of the time, this protection is a fantastic thing. It stops functions from accidentally messing with each other. But what if you actually want your function to change something in the main lobby? For that, you need a special kind of access. You're going to need a master key. Just think about a video game, right? You defeat an enemy inside a function, and you need to update the main global score for the whole game. The shadowing effect we just saw would make that impossible. So, how do we give our function the permission it needs to reach outside its own room and change that global state?
The answer, our master key, is a single powerful command. In Python, that key is a global keyword. It's the explicit instruction you give Python that says, hey, I need to reach outside of this room for a second.
See, when you put global score at the start of your function, it's like telling Python, hold on, for this score variable, don't write on my local whiteboard. I've got a key, and I'm going out to the lobby to change the official scoreboard. It tells the function to find and modify the existing global variable instead of creating a new local one.
And would you look at that? The proof is right there in the output. We start with a global score of 0. We call our defeat enemy function once, and boom, the global score is now 1. We call it a second time, and that very same variable gets bumped up to 2. Our function now has the clearance it needs to directly change the lobby's scoreboard.
Okay, so we've done the full tour.
We've seen the public lobby, we've visited the private offices, and we've even learned how to use the master key. Let's boil all of this down into a few simple rules of the building that you can take with you.
Let's break it down into 3 simple rules. Rule number 1, local is your default. Your local variables are safe, they're independent, and they can't cause unexpected problems elsewhere. Rule 2, global variables can be seen by everyone, so they're great for things everyone needs to read, but you have to be really careful about who gets to change them. And finally, rule number 3, the global keyword is that master key. Use it sparingly and only when you have a very good reason to modify a global variable from inside a function.
And just like that, Python scope isn't so mysterious anymore, is it? By thinking about your code in terms of lobbies, private rooms, and master keys, you can write programs that behave exactly how you expect them to every single time. So the real question is, now that you have the keys to the building, how are you going to design your next project?